Oh.
Right, so if we expand these brackets then. So what we're doing is we've got to remember to multiply this number by both of them. So we've got 2 times the 4a gives me 8a. Yeah, so we multiply that. And then we've got 2 times the plus 3 makes plus 6. Okay. The question I have for you, can we collect any of those terms together? We've got 2 terms, are they like? Can we collect them together?
Yes, we could actually.
You think, can you?
Yes, because there is no sign after the 6, so you could actually...
Yeah, you could add the 8 to the 6 and then...
Yeah, and then you could say it's an 8 because it doesn't have a sign after the 6.
Okay, so if you wanted to simplify, what would you do now?
I'd add the 8 and the 6.
So you think the answer would be,
Add the 8 and the 6.
which would make
14.
14, and you think 14a would be
Well, no,
the answer.
you could divide it by 2.
No, but
You
when
want
you
to
divide
really
by
simplify it.
Why would you be able to divide it by 2?
Make a small number and write
But
down.
But if you divide a number by 2, you change it. When we simplify, we don't want to change.
Oh, it would be 7 A's plus 7 A's.
Well, actually, the problem here is, read that to me. What does it say?
8A plus 6.
Okay. Well, does 8a change depending on what a is?
I don't know.
Well, if I told you a was 2,
Yeah.
8a would be...
A would be 16.
Okay. If I said a was 4, 8a would be 32. So this bit changes depending on what I tell you a is. Does the plus 6 change if I change a?
No.
No, it stays as 6, doesn't it? So actually, these two here, okay, this term and this term, they are not like terms, right? So that means you cannot do that. It doesn't simplify any further. They do not come together. You can only add, so I can add 6 A's to 8 A's to make 14 A's, but I can't add 8A to 6. In the same way I can't add 8A to 6B until I know what A and B are. Okay, so I cannot add 8A and 6. Right? Remember previous lesson we did collecting like terms. That's what we've got here, collecting like terms. It means if I've got A and A, I can collect them. Alright? In this case I can't. Right. So just check another one. If we have minus 3 times 2x minus 5y. Okay. And we want to multiply out this. Any ideas? Girls? Any ideas? What would you say? Be careful. I would say be very careful.
I think it will be negative 6x
Minus 6x, yeah.
plus
Good. Plus.
Negative.
No.
No, it's not negative. It will be just like 15y.
Perfect.
I don't know.
You don't understand that. Okay.
I get why it's plus, but that's it.
Okay. Well, that's a good start. Well, what we do then is we say negative 3 times 2x. Negative 3 times 2x makes the negative 6x. And then the negative 3 times
Negative 5.
negative 5y makes
Make a positive.
positive 15y. So that's why we've got that.
Understood.
Understood and received. Good. Stop doing your homework, Giselle. Close your homework book. Stop doing your homework. That's cheating. That's on video now that you're cheating doing your homework. It's recorded. Don't look at me like that.
This is not a camera,
No, I've just said your voice cheating on your homework.
No proof.
Oh, he talked.
Okay, before we ruin this video
Whoever's
then.
watching this can hack his account.
Okay, so we've got this now. The next stage right? Well, there's no collecting like terms there either, is there? How many terms do I have? How many terms are there? Jaina? 2 terms. An x term and a y term. So we have 2 terms here. Okay. Are they like terms?
No.
No, so we can't collect them. Okay. What we're going to move on to, though, if you don't have any more questions, is something where we have more than one set of brackets.
I don't quite grasp the concept of how you know if they're like terms.
Okay, well, maybe the next bit will explain it for you a bit better then. So, it's hard when we haven't got any like terms to show you. If I do this one, look, so 2 times x plus 3, so that's quite simple, isn't it? But what if I then go plus 3 times x minus 2? So I've actually got a more complex expression with 2 sets of brackets. So when I multiply out these, I've got to do them both separately. So Sophie, go on then,
Can
you're
I
straight.
explain it?
Go on, have a go.
I would say 2x
2x, yeah.
plus 3.
Ooh, careful. 2x,
Or plus 5.
double careful. You've made both the mistakes that people make.
I don't understand.
Because it's times. So 2 times
Can
3
you do x
is
squared?
6.
Can you do x squared?
Where?
Plus 6. And
No, because it's 2 times x is 2x.
alright.
And
And
two-
then for
Then
the
we've
other
got-
one, it would be 3x
Good. So then it's plus
plus
3x.
times plus 3x plus minus 3.
So what's
No,
plus
minus
minus? So it's just minus 6. Good. There you go. Got there in the end.
Kind of a
So that's right so far. Okay.
And then
However,
you add
now we have like terms. How many terms do we have at the moment? 1, 2, 3, 4 terms. But we can simplify by collecting like terms. So, the like terms are, excuse me, anything with an x in it. So how many have got an x in?
2.
2 of them. So and we take the sign with it. Alright? And then we have a different one where terms have nothing, no letters, just numbers. And we take the signs in front. Okay? And what we can do is we collect the like terms together. So, we'll say that we collect the like terms. Now, you won't necessarily do this next bit, but I'm just going to rewrite it, collecting the like terms. So it then becomes 2x plus 3x plus 6 minus 6. So I've because it's plus and minus, I can write them in any order I like. That's fine. As long as the sign stays with the number. That's why I've coloured in the sign as well. Now we collect them. So 2x plus 3x is
5x.
5x, good. And then plus 6 minus 6 is
0.
0. So that's it. So this, all of this is equal to only
5x.
5x. So we've simplified it down to how many terms?
1.
Good. So we simplify to 1 term. So that's the definition of simplifying, is when you reduce the number of terms that you have. Okay? Yeah? Why?
Don't pause it.
We're not talking. Right, we're going to look at another one with more terms to try and help you understand the collecting like terms. Okay? So hopefully you've written that down. Right, so if I give you another one, so for instance, let's have 2a times 3 plus 2b b plus, what should we do? A times 6b plus 2. Okay? Just thought, top of my head. So we're going to multiply this one out. So remember, we do everything times everything. So, first of all, 2a times 3 is
6A.
6a, good. Seraphima, 2a times 2b plus 2b, what do you think that's going to be? Tough one, but perfect. 4ab. So plus 4ab. Okay, so that's the first bit done. Then we've got plus a times 6b. Millie, do you know that one?
6AB.
So plus a times 6b is?
6AB.
Well done. So plus 6ab. And then finally, plus a times plus 2. Jaina?
2A.
So plus 2a. So again, we have how many terms?
4.
4 terms. But we're going to collect the like terms. So, to start with, how many different types of term have we got?
2.
Well, we've got, good, 2. So we've got one term that has a's in. Here and here, sorry. I almost did the wrong one. And then we've got 2 terms that are
AB.
AB. So I'm glad you remembered that AB is not the same as an A. They're separate, they're different. Okay? So what we can do now is collect the like terms together. So again, you won't necessarily write this when you're doing it for real yourself, but I'm going to rewrite it as 6A plus 2A plus 4AB plus 6AB. Now, what I should have done here, my fault, is made sure that the sign goes with that. Okay, the sign stays with the term.
So you add the same number of terms together. No, the
So
same type of terms together.
Exactly. So if it's got just A's, we've got 6A plus 2A is 8A. And then we've got plus 4AB plus 6AB is plus 10AB.
So that was the collecting like terms.
Yeah, that's the collecting the like terms bit. So in this case, we've gone from 4 terms to how many?
2.
2 terms. Okay, so we've simplified it. We've got more terms than the other one, but that's as far as we can go. We can't get rid of any more terms. A and AB do not go together. Okay? Now, of course, there's one more thing we've got to pay attention to. I've got to explain to you. So we'll do that in a second after you've written this down. Right, guys, so if we do this, so this was the question I gave you. So you're struggling here with just this first. So A times 3A, so we've got A times 3A is the same thing as A times 3 times A, or 3 times A, which is 3A squared. Okay? And then we have A times 2B is
2AB
plus 2AB, good.
plus 6.
And then we've got plus what?
B
Why is it
2AB?
6
B
B
plus 2B. I don't get why it's 2AB.
6B squared then. 2AB, you don't get why it's 2AB because A times 2B, 2 times A times B. What did you think it would be? Like what? What's completely
I
different?
thought it was going to be 8A and 7B. I messed up.
Remember, don't forget, they don't go together unless the term is exactly the same. So A times A gives you the A squared. A times the B gives you the AB. Okay, and then this one, 2B times 3B, well that gives you the 2 times the 3 gives you the 6. The B times the B gives you the B squared. And then finally, the 2B times the A gives you plus
2BA,
2BA again. Or
2AB,
2AB. Why would I write it AB instead of BA?
because A comes before B in the alphabet.
I don't need to. That's not the reason. The only reason I've done A times B this way is because it makes it the same as that one, so I don't get confused. Okay? Because BA and AB are the same thing, but sometimes people don't see that. Then I can collect my like terms. So, how many different terms have I got here?
3.
So I've got terms with A squared. There aren't any more, so I've got to change my colour. I've got a term with a plus AB. Is there another AB? Yes, there is. There it is. Another 2AB. And then I've got a term with a B squared. Now there's only one B squared. So when I collect my like terms, how many terms am I going to end up with? 3. So I'm going to have 3A squared plus what?
Plus 6B.
Careful. Plus 6B squared, yeah, I can put that next. And then plus
Plus 4AB.
4AB. Perfect.
Can you give us another one?
Okay, you want another one?
Yeah.
Right. I'll write down another. Okay, looks like you've done this one pretty well. So, Sophie wanted to take us through. So, first of all,
2G times H
Yeah.
is 2GH
yeah,
plus 2G with times
2G times 3G, yeah.
yeah is 6G squared
6G squared, good.
plus
Plus
8H HG
HG, okay.
times 4H squared
So minus the 4H squared, yeah. The like terms. So we've got. Keep going. We've
like
got,
terms are
so we've got a 6G squared,
6G squared
Get rid of that one.
plus 4H squared
not plus.
minus 4H
Good.
squared
Minus 4H squared.
plus 2HG times
Now, 2GH and 8HG, are they the same or different? They're the
different.
same.
You can
Remember
write
I said
down-
this before, HG can be written as 8GH perfectly well. Therefore this one and this
10
one are,
10H.
so then it's plus 10 HG or GH, up to you. So we end up with 3 terms.
Does it matter what order you put them in?
Nope. Not really.
Can we do them one last time?
One last one.
Yeah.
Okay.
It is right.
Okay, let's go through this answer, so be double careful. Right, go on then, Tabitha, you wanted to tell me.
Okay, so first you do 3 times 2x
Yeah, makes
makes, sorry, my brain's gone, 6x,
6x, yeah,
and then you do 3 times 2y,
makes,
which makes 6y,
so plus 6y, don't forget the plus or the minus, okay?
then minus 4y, which makes negative 8y,
Cool.
minus 6x, no, minus
So minus 2 times minus 3 makes,
a positive, so 6x,
so let's say it, plus
plus
6x. So good, I'm glad you actually didn't put a plus in the middle because it is minus 8y minus 2. Now quite a lot of people make a mistake of leaving that as minus, and it's not, okay? So it's minus 2 times minus 3, so I'm glad you got that. Yeah, did everyone get that right, that plus bit at the end?
And then you put them together.
So collect the like terms, so we've got 6x,
12x.
good, 12x.
And I'm not sure whether it's a plus or a minus here.
Well, it's not the rule, is that we've got plus, we're at plus 6y, and we subtract 8y's. So if we're at 6,
2y.
so what?
Negative 2y.
Yeah, well done.
So
Minus
there's
2y.
2 terms.
So we're left with 2 terms, yeah.
But like 6x plus 6y, all of those are 4 terms, right?
Exactly.
mean I
So we
actually
have 4
understood that?
terms here, and we simplified to 2 terms.
I mean, I actually understood that.
Looks like it. Who'd have thunk it, eh? You actually understand it. And that's the end. And you have to go to whatever lesson you need.
Right.
No, we have not. Oh, no.